Alright, now we're going to install Prisma, which is a very popular ORM or Object Relational Mapper. We use ORMs to work with our databases. So an ORM is like a tool that sits between our application and a database. We use this ORM to send queries to our database and get data back, or use it to create, update, or delete data. It's very simple. Now, in this course, we're just going to scratch the surface of Prisma. There's so much more about Prisma that goes beyond the scope of this course, because our focus here is on Next.js and not Prisma. For Prisma, you either have to take a separate course or just read the documentation. But in this section, I want to teach you the foundations so we can learn more advanced topics on your own. Okay, so back in VS Code, first we're going to install an extension for working with Prisma. So let's search for Prisma. Here it is. This is the official extension from prisma.io. Let's install this. All right, beautiful. Now, this extension gives us auto-completion, syntax highlighting, formatting, and so on. It's very useful. Next, we're going to go in the terminal and install Prisma. Lovely. Now, Prisma comes with a command line interface that we can work with using npx. So if we type npx Prisma, we can see examples of commands that are available to us. Up here, you can see all the available commands. So we have init for setting up Prisma in a new app. We have generate, db, migrate, studio, and so on. So let's run npx Prisma init to set up Prisma. All right, now this command does a couple of things. In our project, it creates a Prisma folder and puts a schema file in this folder. We'll come back to this in a second. It also creates an environment file where we store our environment variables, in this case, a database URL. Now, by default, Prisma uses Postgres, but in this course, we're going to use MySQL. There are other database engines that are available, so we're going to change this connection URL or connection string to something that is compatible with MySQL. So if you go to Google and search for Prisma connection string, you will find this page, connection URLs. On this page, you will see examples for Postgres, MySQL, SQLite, MongoDB, and so on. Now, look at MySQL. What we need to do here is that we go to the schema file and set the provider to MySQL. You will see that in a minute. But we should also change the connection URL to something like this. So first we have the connector, which should be MySQL. So in here, we should change Postgres to MySQL. Then we add our user, followed by a colon and a password. So for Postgres, I think the default user is Postgres. In MySQL, it's root. So we add that, followed by a colon, and then the password for the root user. I set up my password to my password. I think that's it. Then we add an @ sign, followed by localhost and port. 5432 is the port for Postgres. We should change it to 3306. Then we have / and a database name. We're going to change that to Next app or whatever you like. Now, for MySQL, we don't need this query string parameter, so let's remove that. So this is our environment file where we store our database URL or other secrets. We don't want to include this environment file in our source control because it would be exposed to anyone who has access to our code repository. So we need to go to our git ignore file and add .env somewhere here. But we have .env.local. We should also add .env. So we're done here. Now let's go to our schema file, which is in the Prisma folder. In this file, we have two blocks, generator and data source. Generator is for generating a Prisma client, which we're going to come back to later. Data source is where we specify our data source or database. Here we need to change provider to MySQL or any other providers you use like MongoDB and so on. Now for URL, we are loading the database URL environment variable, so we don't need to change it here. We're done with this step, so next we'll define our data models. All right, now we're going to define our data or application models. These models are entities of our application domain. For example, in an e-commerce application, we have entities or models like product, customer, shopping cart, order, and so on. So let's go to this Prisma schema file. In this file, we define one or more models. So we add a model block. We give our model a name, let's say user. Now for naming these models, we use the Pascal case. So we capitalize the first letter of each word. Okay. That a model can have properties or fields. For example, we can say our users have an ID field. The type of this is int. Now look, this auto completion comes from the extension that we just installed. So here we have int. If we add a question mark, we make this field or property optional. So by default, all fields are required. Okay. Now we can add square brackets to turn this to a list. We also have big int for storing larger numbers. So let's go with int. Now we can optionally apply one or more attributes to a field. For example, here we have an attribute called ID. With this, we're saying that this is an ID field that uniquely identifies each user, that each model can have only one ID field. Okay. Now we can also give it a default value using the default attribute. So we call this like a function and provide a default value. The value can be a scalar value like 1, 2, 3, 4, or here we can use the auto increment function. So we let the database generate new IDs for us. Then we can add another field like email. We set the type to string. We can optionally apply another attribute called unique to make sure we don't end up storing two users with the same email in our database. Let's add a few more fields like name of type string. We add followers of type int. We can give it a default value of 0. Well, I forgot the @ sign. And let's add one more is active of type boolean and give it a default value of true. We have an extra parenthesis here. All right, good. So this is our user model. Now we can ask Prisma CLI to reformat this code and make it more readable. So here in the terminal, let's run npx Prisma format. All right, now take a look. Our code is beautifully formatted, okay? So this is how we can create a model in Prisma. Now in this example, we're using basic or scalar types like int, string, and boolean. But there are more types supported in Prisma for building more complex models. If you Google Prisma model, you will find this page. On this page, you will see various examples. For example, look at this user model. In this model, we have fields that are other model types. For example, we have posts, which is an array of post models. Post is defined down here. We also have profile, which is an instance of a profile model, which is optional because of the question mark. So in this case, a user model has a relationship with other models like role, post, and profile. Now, I'm not going to cover relationships in this course because there's so much about relationships that we have to cover, and I want this course to be practical. I want you to learn the foundations without getting distracted with too much complexity. So let's cover the big picture first, and then you can learn about relationships on your own, or maybe in the future I will create a course for you, okay? So read this page and see how we can define more complex models. Now, as we define or change our models, we have to create migrations. These migrations are used to keep our database schema in sync with our Prisma schema. Let's see them in action. So here in the terminal, we run npx Prisma migrate dev. If you're using a relational database like MySQL or Postgres, you run this command. If you use Mongo, which is a NoSQL database, you run npx Prisma db push. So let's run npx Prisma migrate dev. Here we need to provide a name for this migration. We can say this is the initial migration. Let's see what happened here. So this command created a migrations folder. In this folder, we have another folder for our first migration, which is called initial. Just before that, we have a datetime step. This way we can see all migrations in order. So let's see where this folder is. It is here in the Prisma folder. We have migrations. Here's our first migration. In this folder, we have a SQL file. And this file has instructions for creating a database table called user with these columns. Now, if you're not familiar with SQL, that's totally fine. I have a comprehensive course on this topic if you want to learn. But basically in this file, we have instructions for creating a table with this name and these columns. Now, the type of these columns is based on the user model that we defined in our schema. For example, ID is an integer, email is a varchar with the length of 191. That varchar means variable character. Varchar in MySQL is like a string. Now, the type of these columns will vary depending on the provider we use. For example, if you use a Postgres database, you will see that the type of these columns will be different, okay? So when we run Prisma migrate dev, Prisma CLI creates a migration and applies it to our database. So now if you go to our database, we'll see a table called user. In this lesson, I'm going to use data grip to connect to my database. So here, we add a new data source, MySQL. On this page, we set the user to root and password, and the database to Next app or whatever we use. Currently, I'm missing driver files. Unfortunately, that is not visible in my recording window, but down here, there is a link saying download missing driver files. If you're using data grip, the first time you have to click download to download these driver files. And if you use MySQL Workbench, you're not going to see this arrow. Now down here, we have a link called test connection. All right, connection is successful. So let's connect to my database. Lovely. So here's the Next app database. In this database, we have two tables. Prisma migrations, which is prefixed by an underscore, which means this is private, and implementation detail. It's only for Prisma. In this table, we can see all the migrations that have been applied so far. So each migration has an ID and a bunch of other properties. Here you can see the migration name. That is the folder that was created in our project. So over time, as we define or change our models, we create new migrations and apply them to our database. Using this table, Prisma CLI can track what migrations have been applied to this database or not, okay? Now, back to our database. Here we also have the user table with these columns, ID, email, and so on. Now, if we double click on this, we can see the data. Currently, there is no data in this table, but we can easily add a record by clicking on the plus icon. So ID is automatically generated. We're not going to touch that. For email, I'm going to type programmingwithmosh@gmail.com. Let's set the name to Mosh, and we can leave the other columns empty because we supplied default values for them. Now we can click on this icon to submit our changes to the database. Now back to our project. Let's go to our schema file and add a new field in this model. Let's say registered at. We set the type to date time and give it a default value of now. So now is another built-in function in Prisma. So we have made a change here. Now back in the terminal, we can run npx Prisma format to reformat our schema. That looks beautiful. Now we should run npx Prisma migrate dev one more time to create a new migration. Again, we need to provide a name for this migration. So here we can say add registered at. So by giving meaningful names to our migrations, we can see what kind of changes each migration brings. Okay, now let's take a look at the new migration file. So here we have a new folder. Again, you can see the timestamp. Here's the folder name add registered at. Here we have a migration file and a SQL statement for changing the user table to add this column. Now, if you go back to our database and refresh this table, we can see here we have a new column. Beautiful. Now, to work with our database, first we need to create a Prisma client. So here in the Prisma folder, let's add a new file called client.ts. In this file, first we import Prisma Client from @prisma/client. Then we create an instance of this. We can call it Prisma and set it to new Prisma Client. Now in this object, we have access to the models we have defined in our schema. For example, we have the user model. And here we have methods for creating, reading, updating, and deleting users. For example, we have find many for finding a bunch of users. We have create for creating a user, and so on. So anytime we define or change a model and then create a migration, Prisma CLI automatically generates or regenerates this Prisma client, so it's always in sync with our models, okay? Now, we create this object and then export it as a default object from this module. Now, technically, we can create this Prisma client anywhere in our application, but as a best practice, we should make sure that there is only a single instance of this running our application. So the reason we are doing this in this file is because the first time this client file is imported somewhere in our application, we get a new instance of this Prisma client, but the second time this file is imported, this code is not re-executed, it's cached, so the result will be reused, okay? Now, in Next.js, because we have fast refresh, anytime we change our source code, Next.js refreshes some of our modules. In that case, we'll end up in a situation where we have too many Prisma clients. So you will see an error in terminal saying too many Prisma clients. This only happens in development because fast refresh only happens in development. So to go around that, we have to borrow some code from Prisma documentation. So go to Google and search for Prisma Next.js Prisma Client. You'll find this page, best practice for instantiating Prisma Client with Next.js. Now on this page, you will see the actual code. Very briefly, what this code is doing is that it's using this global namespace to store a single instance of Prisma. So when initializing this constant, if there's an object, if there's a Prisma client in the global space, it's used. Otherwise, a new Prisma client is created. That I know it's a little bit confusing. Don't worry about it. It's something you do once and you never have to come back to it. So let's just copy this piece of code, paste it here, and we're done with this. With all the pieces in place, now let's see how we can get data from our database. So let's go to the API folder, open the users folder, and then go to this route file. Now we're going to change this get function. So instead of returning hard-coded data, we're going to return data from our database. First, on the top, we import Prisma from Prisma/client. So this is the client file that we just created. Take a look. In this file, we have exported a constant called Prisma. So we import Prisma in curly braces. Now in this function, we call Prisma.user.findMany to get all users from our database. Now we can optionally provide an object and filter our users. For example, here we can set where to an object. In this object, we can set email or any of the properties to some value to filter users. Now we can also provide multiple filters. We can combine them using logical and or logical or. It gets too complicated. For that, you have to look at the documentation. Okay, so let's get all the users. Now this returns a promise. So we awaited to get our users. Next, we make this function async. And finally, we return all these users in the response. Okay, now back in the browser, let's go to API/users. All right, here's what we have, beautiful. Now let's see how we can fetch a single user. For that, we have to go to our other route file, the one in the ID folder. All right, here's another get function. So once again, on the top, we import Prisma. Then in this function, first we call Prisma.user.findUnique. Now, when calling this, we provide an object. In this object, we set a condition. We set where to an object. And here we set ID to params.id. That is the parameter that we pass here, okay? So earlier we added params. We used destructuring. I know the syntax is a little bit confusing, but trust me, over time, everything becomes second nature. So we call findUnique. Again, this returns a promise. So we'll wait it to get a user object. Now let's make this function async. That if this user is not found, we'll get null. So we have to change this condition and say if user is falsing, then we return this error. Otherwise, we return the user object in the response. Now, back in the browser, let's go to users/1. Technically, we shouldn't say this. I don't know what I did wrong. Let me save the changes and refresh. All right, so our application broke. If you look in the terminal, you will see an arrow saying argument ID, invalid value provided, expected int, provided string. Let's see what's going on here. So back to our code. Here in the get function, look, if you hover over this ID property, you can see the type is number. This is based on our user model. However, what we provided, which was prompts.id, was a string, because the values that we have in URLs, even though this is a number, is treated as a string. So earlier I made a mistake. I set the type of the ID property in the prompts object to a number, but this has to be a string because this is the actual value we get at runtime. Now, over here, we have to parse the string into a number like this. Okay. Now, let's hit this endpoint one more time. There you go. So this is the first user. Beautiful. If we go to users/2, we get user not found. Perfect. Now let's see how we can create data in our database. So we go in the users folder and open this route file. Here in our post function, we validate the request data. If it's not valid, we return an error. Otherwise, we create a user object and store it in our database. So here we call prisma.user.create and give it an object. In this object, we set data to the data that we want to store in our database. Here we can set this to body, but as I said before, this is not a safe way because a malicious user can supply additional properties in the body of the request. We don't want to get anything blindly and put in our database, especially when working with NoSQL databases like Mongo. So a better way is to explicitly set properties here. So we should set the name to body.name and email to body.email. The other properties are not required because we gave them default values. So let's go to our schema file, schema.prisma. Look, each user has an ID that is generated by the database. We also have email and name, but the other fields like followers is active and registered at. They have default values, so we don't need to provide them. So in this case, we're only reading these two properties from the body of the request. We call this method add awaited to get the user object that was inserted in the database. This user object will have an ID property that we can return to the client. So instead of returning this hard-coded object, we're going to return the user that was created. Now there is one tiny issue here. Earlier, we defined a Zod schema to validate the request body. Currently, we're only looking at the name property, but we should also expect an email. So we set this to z.string.email. So it's a valid email. Now let's test this. So we go to Postman and send a post request to the user's endpoint. Here, pass an object with two properties name, which I set to John, and email, which I set to john@smiths.com. Let's send this. All right, this was created. Beautiful. And look, this is the ID of John, which is 2. If we create another user by the same email, we should get an error. We got a 500 or internal server error. That is because of the unique constraint we put in the user model. So to handle this properly, before we create this user, first we should check if there's a user by this email. So here we call prisma.user.findUnique. Then we pass an object. Here we set where to an object. And here we set email to body.email. So we look up this user like this. Now we have 2 user objects. So we need to rename this to new user and return it here. Okay. So we're reading this user. Now, if this user exists, then we return an error. So next response user.json. In this object, we can add an arrow and say user already exists. And for status, we should also use 400, which means bad request. Okay, let's test this. So back in Postman, send. All right, now we got a 400 response, beautiful. And the error says user already exists. So let's change the email and add John1. Now we get a new user with a new ID, beautiful. All right, now let's see how we can update a user. So here in the ID folder, let's go to our route file. In this put function, first we validate the request. If it's not valid, we return an arrow. Otherwise, we should check to see if this user exists in our database. So here, we call Prisma.user.findUnique, exactly like what we did in the previous lesson. We give it an object with where set to an object. Here we set ID to params.id. That just like before, we have to change the type of params.id to a string, so we can parse it as a number. Parseint. Good. So we await the call to get a user object. Now, if the user object doesn't exist, then we return an error. Otherwise, we update it in database. To do that, we call Prisma.user.update and give it an object with two properties. The first one specifies the user that we want to update. So we set where to an object. Here we set ID to user.id. The second property is data, and this is the data we want to update. In this case, we want to update only two properties, name and email. So we set name to body.name and email to body.email. Again, we don't want to update all properties that are sent in the request, only specific ones, okay? So we update a user, then we await the call. This returns the updated user, so we store it here, and then we return it in the response. Updated user. So let's test it real quick. Back in Postman, we're going to send a put request to users/1. And here in the body, I'm going to set the name to Mosh Hamedani and email to mosh@hamedani.com. Send. All right, this was updated. Beautiful. All right, the last piece of the puzzle. To delete a user, first we should check to see if the user exists or not. We have done it before. One more time, we call Prisma.user.findUnique. We supply our criteria. We set where to an object with ID set to parseInt of params.id. And here we should change the type to string. Good. Now we await the call to get hey user. Next, we make this function async. Then we change the condition, so if the user doesn't exist, we return an error. Otherwise, we call Prisma.user.delete. We also have delete many for deleting many records. Here we supply our condition. So we set where to an object. Here's set ID to user.id. As simple as that. Of course, we need to await the call and then return an empty response. So let's test it. Let's go to Postman and send a delete request to users/2. All right, the user is deleted. Earlier, you built this API for managing products. Now, as your exercise, I want you to use what you have learned in this section to store these products in our database. It shouldn't take more than 10 minutes. So pause the video, work on it, and then come back see my solution. Alright, first we should go to our Prisma schema and define a new model. So here we add a new model called product with 3 properties. ID, which is an integer. It's an ID field with a default value of auto increment. Then we add name of type string and price of type For this, we're going to use float. I didn't cover this before, but with float, we can store numbers with a decimal point. So this is our product model. Now we go into terminal. I run npx prisma format. So our code is beautifully formatted, lovely. Next, we create a migration to bring our database up to date. So npx prisma migrate dev. We give the new migration a name like create product. Good. Now, if we check our database, we should have a new table for storing our products. There you go. Here's our table with these 3 columns. Lovely. Now, back to our API. On the top, first we import Prisma. Now, in the get function, we call Prisma.product.find many. We await the call to get our products, and then return the result in the response, products. Now let's make this async. Now similarly for our post function, first we validate the request. If we have a validation error, we return it. Otherwise, we call Prisma.product.create. Here we set data to an object. In this object, we set name to body.name and price to body.price. Good. So we call create and await the call to get the new product. And finally, we return it to the client. As simple as that. New product. Now let's test this real quick. So back in Postman, let's send a post request to API/products. And here in the body, we include the name, which we can set to milk, and price, which we can set to $2.50. Take a look. So we send this. We got an internal server error, so I should have made a mistake. So back in the terminal, look, we have an error saying cannot read properties of undefined reading create. I'm not sure what is going on here, so let me restart the development server and call this API one more time. Alright, beautiful, it was created. So it was a temporary issue with the cache.